Hello everyone, welcome to the next question in the series. Here we are going to see a very beautiful question. It says we have to reverse a linked list in groups of k. Okay, so before solving any question or approaching to the solution of the problem, you have to read the question twice or thrice. Okay, reading the question as many times gives you a very clarity about what the problem statement actually looks like. Okay, so if you read this question properly, you'll see that we have to reverse a linked list, that too in groups of k. So you have two tasks. First, the task is to reverse the linked list. That is what we have to do. But the constraint is we have to reverse it only in groups of k. For example, if you look at an example, you will see, let's suppose k is equal to 3. Okay, we have assumed the value of k is equal to 3 and we are given a linked list as input. Okay, so it starts from 1 points to 2, 3, 4, 5 and 6 and so on. Okay, so let's suppose for the time being we have a linked list which contains 6 elements, each pointing starting from 1 and each points to the next element. Okay, so if you have to solve this question based on this example, so the output should look like something like this. The output would be 3 2 1 1. It points to 6 5 and 4. Okay, so what happens if you look closely, you'll find that the elements have been reversed in groups of 3. Okay, the elements have been reversed in groups of 3. And if you look more closely, you can see two lists, isn't it? There are lists of groups k which are reversed at their places. Okay, so if you look closely, you'll find key. Let's make this example on next page. Okay, so the for suppose the example is 1 2 3 points to 4 5 and 6. Okay, it ends here. So the output will be something like 3 points to 2, 2 points to 1, 1 points to 6, 6 points to 5, 5 points to 4, and then it points to 9. Okay, so if you look closely, you'll find the elements of the linked list are reversed at the places, but only in groups of k. Okay, for example, see, suppose if there are 9 elements, so it will be something like 3 2 1. I'm assuming 1 and it goes up to 9. Okay, so 3 to 1 will be there, and then 6 5 4 will be there, and then the next group will be something 9 8 and 7 will be there. Okay, we've taken an easy example. So 1 starting from 1 goes up to 9, so the output would be something like this. Okay, so till here it is clear. So till here we can know that we have to reverse the linked list in groups of k. It's quite clear by seeing the example and output part. Okay, if you have seen my previous video, you'll easily find how to reverse a linked list in whole. Okay, from starting up to the end, how to reverse the linked list. It's a very small process for reversing the complete linked list. So I write that. So if you see my previous video, you can find out that if you want to reverse a linked list completely from starting up to the end, there was a very small code for that. It was a 4-step process. We had to follow it. Okay, so I assume that everybody is quite comfortable with this 4-step process, how we are going to convert the links and how we are going to reverse the linked list on the whole. But we need to convert this code in such a way that it should reverse only, say, for the first k elements. Okay, for if I say reverse the linked list but reverse only the first k elements and leave the next part as it is. Okay, so by making small changes into the code, we can very easily replicate this whole requirement. Okay, so let's suppose I initialize a counter. Okay, because I'm talking about first k variable, so definitely we should have something to keep count of till what position we have reached. So I'm initializing a count variable as 0. That's what do I need to do. I just put some condition with this count variable and follow the same process. What I'll do, I'll say next is equal to current of next. Okay, and then I'll say current of next is equal to previous. I'll update the previous is equal to current, and then I'll update my current is equal to next. Okay, since you have taken the counter variable, there has to be done something. We should do something with this counter variable. So what can we do? Pretty easy. We can increment this counter. Okay, so we can increment the count and we can say count और यहाँ पे plus plus. Okay, quite clear. What should be the condition? Okay, one thing to sure कि हाँ चलो current not equal to null will be there. What else can we have? Okay, can we say while count less than k? Does it make sense? Obviously we have a k, that is the number of elements in the group. We have to reverse only the first k element. So what we do, we have to keep count of this counter, and we have to check if this count's value is less than equal to k. Up to that position, if the value is less than k, so we can follow this whole process, and as soon as this value becomes k, we have to break the loop. So what condition should we use? We should use AND over here. Okay, so this is the code, to reverse the first k elements. Okay, first k elements in the linked list. Cool. Okay, so if we look at this code, suppose we have a linked list. Okay, we have a linked list. If I pass the linked list, as you all know, this linked list consists of addresses, isn't it? Linked list consists of references. So each element lies separately in the memory. Linked list is not just as I draw in the pictures. It's not a continuous list. It's a interconnected links of elements which points to the next element, and the next element points to the next pointer in the list. Okay, cool. It's something like this: 2, 3, suppose 5 is there. So suppose this is a linked list. Okay, so what if I run this procedure? What will happen if I run this procedure? First of all, let's talk about this. Okay, first procedure. If I run the first procedure over this whole list for the first procedure, okay, so if I run this first procedure, what will be the output? The output will be something like 6, 7, 6, 5, 3 and 2. Okay, but what about the second procedure? What happens when I run this second procedure with the value of k as 3? Suppose the value of k is equal to 3, because it says we have to reverse only the first k elements. Okay, so if we run this procedure from here, from starting from 2, the output will be something like 5, 3 and 2, isn't it? It will reverse only first 3 elements, and what happens to the rest of the list? The rest of the list is pointed by next. Okay, and 7, and at the end of this process, this will be the head, this will be this the head will be, this element will be head, and this element will be previous. If you see my previous video, you'll get an idea what is actually happening. Okay, so the pointers will be something like this. The arrangement of the pointers will be like this. Okay, cool. So we are quite clear up to here. Okay, what happens if I run the same procedure starting from 5? Okay, forget anything before 5. What happens if you run this procedure starting from 5? Okay, so if you run it from 5, what happens? 5, 6 and 7 is there. Okay, 5 is there, 6 is there, and 7 is there. Okay, so 7 will start pointing to 6, 6 will start pointing to 5, and 5 will point to, suppose 5 will point to null, isn't it? So the list will change. So we have this procedure, and we have an idea कि whatever point we will start running this procedure from, it will reverse k elements starting from that point. Okay, so with that notion in mind, let's start with the question. So suppose the list that we got was like this. Okay, coming back to the same example with k's value is equal to 3. Okay, so suppose I call this reverse function. Now I'm talking about this second function what we have devised. Okay, forget this one, we will use this second function now. Okay, so what happens when I call this second function starting from first element? What will happen? Look closely. Okay, so won't it be something like 1 is pointed by 2, 2 is pointed by 3, 1 points to null, this is head, and this is previous. Okay, cool, and this will remain as it is. Okay, the next part in the list remains that it is pointed by next. Okay, cool. So can you tell me one thing? Don't you find a sequence of or a interrelated sequence what we wanted to devise in the beginning of this algorithm? We wanted groups, and that too of k. Okay, so looking at this first part of this problem, you can easily see that we already have a list that has been reversed in groups of k, and remaining is the a quite straight list that is not yet visited or traversed or reversed, but it has a starting pointer that starts from next. It's quite similar to a very new linked list. Okay, so what happens, so suppose we have run this whole procedure over here. Okay, the second procedure over here. So what it does, it reverses this linked list. What happens if we run that procedure over here? What it does, it changes the links. Okay, it changes the links. So what it will do, 4 is there, it will be pointed by 5, it will be pointed by 6, and 4 points to null. Okay, suppose we have run this procedure 2 times. Okay, so look closely what happens. What happens, we will get 2 groups. Okay, 2 separate groups. One is 1, 2 and 2. Let me make it more clear. Okay, so we'll get 2 groups, 1 pointed by 2, pointed by 3, and if I run this procedure over here again, it will say 6 pointed by 5, pointed by 4, and then this points to null. Okay, so what more do you want to do? Okay, this will be the head. Okay. What more do you want to do? This will be the previous. Okay, don't you feel like if you want, and what is the output that we are seeking? So the output is something like 3 points to 2. Let me change the color and then it will be more clear if I change the color. Konsa, this one is good. Okay, so 3, oh my god, suppose this color. Okay, so the output will be something like 3 points to 2, points to 1. Okay, then 6 points to 5, points to 4. Okay, take your time and devise this output. You'll find it is same. Okay, they are forward links. Okay, so our output should be something like that. So if we look closely, we have one part that is quite similar to our output, 3 points to 2, 2 points to 1, and then we have a second part that points to 6 points to 5, 5 points to 4. It's quite similar to the output required. Okay, but the only thing is a link between the two is missing. Okay, what is the link that is missing? This is the link that we want to establish. We want to connect this 1 to this 6. Okay, you want to connect this 1 to the 6. Okay, what does this link represent? Isn't this link head of next? Okay, head of next. And what is this group? What does this group represent? Standing at this point, if you talk about this point, isn't this point the next element? Okay, look here. If you are reversing, where is that? Yeah, if you are reversing the first, if you are reversing the first k elements, where does the next stands now? The next stands on the kth element, isn't it? So isn't it this very next element that should occur in the list? Okay, this 4 is the next element that represents a completely different linked list. Okay, so starting from 4, if we call this function on 4, what happens? It reverses this whole linked list in groups of k. What do we do now? We are just connecting the next of this head pointer to the reverse called on 4. Okay, isn't it? And what is this 4? This 4 is next. Okay, what do you want to return in answer? What is our answer now? Since our list becomes 3, 2, 1, 3, 2, 1, 6, 5, 4, what do we return? Don't we return previous? Isn't it? We have to return the previous. That means this is the head.next is called reverse of 4, and then we have to return a previous. That's it, and our task is done. So what additional thing we are doing? We are pointing heads next is equal to, and then we are calling that reverse function or whatever that procedure's name is, and then where are we calling it? We are calling it on next element with that same value k, and then we are returning this previous pointer, isn't it? This is what happens. So if you connect the dots, if you are following this video clearly, this is the procedure to reverse the elements in groups of k, and this is the procedure to connect the elements in various separate groups. Okay, So let's see the whole code, how it goes. So the whole solutions, the whole code for this question is very simple. It's very easy. So if you look at the solution, we have a function whose name is reverse, and then we have to definitely return a node. That is, we have to return the linked list. Okay. So we get head as input, and then we definitely get this value k as input. Okay. This is the parameter that we get. Okay. What do we initialize in the beginning? We initialize a variable called current and initialize its value to head. We declare a variable node, we declare a variable previous, and then we declare a variable count. Each initialized to the default initial value. So next is null, previous is null, and count is equal to 0. This is the first part, easy part. Okay. What do we do then? We just reverse the first k elements of this group. Okay. So we got this list. We don't know the length of the list, but we reverse the first k elements of the list. Okay. And then after reversing the first k elements, next points to the completely different list. Okay. If next exists, so what do we have to do? We have to reverse the next also and connect the links. So we have to reverse the next elements and we have to point it with heads next. But when do we do it? There should be next should be pointing to some element, isn't it? There might be a chance that only k elements are present and everyone is reversed. So next will be pointing to null. Okay. So we need to check if next is not equal to null. Okay. So there is next is not holding some bogus value. Then only try to reverse starting from next. And what happens when you reverse it? Okay. So we had this link which we reversed in k. We had this linked list which was pointed by next. We have reversed it. What did we do? This was previous. We just connected, isn't it? We connected heads next to reverse of next, isn't it? This we have done. And what did we return? We return this previous. So you return the previous element. That's it. That is it. And then we are done with the code. So you can take screenshot of this and try to dry run it first. Okay. If you're new to coding, try to dry run every problem that I teach you. So that will make a grip in your mind, and then it will give you more understanding of the problem. Okay. So problems are understood more better when you start practicing on your own. You start writing them, making dry runs of it, try to implement on your own logics. Then you'll get this understanding much better than what I'm teaching. Okay. So there might be a chance you might understand more than what I'm teaching. Okay. But that will happen only upon practice. So start practicing, start coding. So that's it from this section. Okay. I hope you like this video. So feel free to leave your comments and feedbacks. I love to hear from you. Okay. This will help me, make my videos more interesting and interactive. Okay. So thanks for your time. Thank you so much. Bye.